So this session will be a tutorial for doing DNA interpretation with EuroForMix. In this session you will learn how to import data, how to carry out the DNA interpretation, and also learn what is required from the DNA interpretation in your report. So the first thing I do is to open EuroForMix, and now I want to find the tutorial data. The easiest way to find it is to right click on this button and look for the directory which this point to, the tutorial data directory here, and I want to copy it to the desktop in order to have easy accessible to it. So I will go on and find the folder on the computer. So here is the tutorial data folder. I will copy it and paste it into the desktop. I'm doing this because I want to have easy access to all the data in this folder here, which will be the stain profile, reference profiles, and so on. So my tutorial data lays in this folder here with a stain profile. It's a reference profile. Actually, there are two reference profiles. It's P1 and P2. And we have a folder here with all the allele frequency data. So it's actually enough with one single file with the corresponding file which you want to use in your analysis. So I will now show you how to do DNA interpretation with this data here. First of all, I select directory and I select the folder of the data, the tutorial data folder, and I put freq databases where my allele frequency file is. Now I can see that this folder has been selected, and I left click and it's importing the allele frequency file in the selected folder. So first I import the evidence profile and the reference profiles. So what I will be interested in this session here is to calculate the likelihood ratio for that the P2 is a contributor to the evidence and P2 is not a contributor to the evidence. First you should check that all your data are correctly imported. So what you will do though is to select all these imported profiles, and you first can check the references and check that they are correctly, and also checking the evidence profile. You can also look on the EPG like this. If we look on the P2 profile, we can see he has dropout here, 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 down there, and here, in case if he's the contributor. We can also see that in one marker here, the alleles of P2 is laying in a stutter position of 19. So let's go back. We also want to take a look on the peak height summaries, which is the sum of the peak heights for each marker given as a function of fragment length. So we see that there's a clear degradation slope here. So we see here that one marker is amplified much more than other markers. The thing you want to do after you have import data is to save the project. So we can save it here, go into the working directory and write. This means that we can close the software and open again and open the project and open the project again. And then all the data should be imported directly to the software. So the first thing you have to do when you carry out your analysis is to first check your allele frequency data. So here I select ESX17 and Norway, and you can click on this button to view the allele frequencies and see that they correspond to the allele frequencies in your file. So what I do first here is to click the settings button, and you will see here that we have a easy mode. I will turn this on in order to guide the reporter be provided with a more streamlined analysis. So in this analysis here, we will use detection threshold 150 RFU, and we put the FST correction as 0, we will start by assuming no drop-in in the model. That is what we start with here. Then we click save. So every time you click save here, this is memorized in the software. So now we want to calculate the weight of evidence. We start by clicking weight of evidence. We start by assuming 2 contributors to the mixture. Assume a model first without degradation and without stutter. So we click here. Okay, so we got a warning now. We have to re-specify the model. So we extend the model now with an extra parameter. There are stutter in the evidence. We need to explain with a model. And both HP and HG was successfully calculated. We can take a notice on the log likelihood value here. We can compare this log likelihood for this model with this value for other models. So we will use this number here for model selection. So the higher number you get, the better the model is fitting the data. And we also register the LR here. What we do now is to go back, and we can also try the degradation model here. So now the number is drastically increased, and the LR is also increased a little bit. We can also increase the number here to assume 3 contributors instead of 2 contributors. And if we do this for all the combination, we end up with a table like this. You start with the simplest model. We assume 2 contributors without degradation model and without stutter model. Relative number of parameters, we start with a baseline. And as we increase the number of parameters, we also expect the log likelihood to increase. What we will do here now is to adjust the log likelihood, maximum log likelihood value with the number of parameters. So we penalize with the number of parameters here. And if we also increase the number of contributors here, we see that a model with 2 contributors with a model with degradation and stutter is giving the maximum adjusted log likelihood value. And we will base our reported data on this model here. So what we have to do to go back and change the model to the selected final model, the model with the largest adjusted log likelihood value, and we infer the model again. So after that this has been carried out, what we will do next is to do model validation. So we start by clicking under HP, the model validation. And what we observe here under the assumption that the underlying model explains the observed peak eyes is that these points here, they are following this straight line here. If any of these points are outside the envelope here, we react the assumption that the underlying model is representative for observed peak heights. So we do the same under HD, and we also see that none of the points are outside the red line. It could be difficult to see whether points are outside the red line sometimes. What is possible to do is to go to the terminal and look for this printout here. If any of the peak heights are outside this red envelope, this will be listed here in the console. And the next step in the analysis is to do a likelihood retro sensitivity analysis. Selected under MCMC, set number of samples. The default is 2000. We can start with that and see how long does it take to calculate. So we click LR sensitivity. So the HP is always faster than HD to calculate since there are less unknown in this proposition. The simulation was completed and we obtained a log 10 LR 8.7. Every time you click LR sensitivity, you expect to get a change in the number. In order to decrease the variability of this number, we can do this over again, but we select 5000. So now the button is stuck there. What you can do then is to click it out and try again, 5000, okay, and run again. And after a couple of minutes, the simulation is done, and we see the number is about the same here. Close this window, and now we can save all the calculated result in a report. Create a report file by writing report. We can go into this file here and look on the report. So this report will tell you what version of EuroForMix you used and what version of R package you installed, the username, when the report was created, what data has been used in the calculation, the detection threshold in RFU, FST correction, the probability of drop-in, number of contributors, what contributor was known under each of the hypotheses, and also which one is the non-contributor under HT. So all the maximum likelihood estimates of the parameters are given with corresponding standard error, and the maximum likelihood values are given, and also the LR simultaneously for all markers, and also each marker separately. And in the end, also the conservative LR, which is based on the LR sensitivity analysis, and also the number of MCMC samples. So to summarize, what you want to include in your final report is the table of model comparisons. This means this will be the table of the comparison of the maximum log likelihood values and the adjusted one and the corresponding likelihood ratio and the corresponding model situations. And the second part is the model adequacy check. Will be a plot of the PP plots under each of the hypotheses and also the generated report file, which also include all the model specifications and the numerical likelihood ratio values.